over a log, can't split. So let's work a problem. Yes, one single log in order to use it. And it also works for natural logs, by the way. Given that, we've got the same given, so let me just go up and copy it, so I don't have to. So same logs. We're asked to find the log of 3/5. We just did that, didn't we? Log of 3/5 would equal the log of 3 minus log of 5. I think on your homework, let me give you a heads up, they kind of made this one easy on you, because they gave you, okay, well there's a 3, there's a 5. On your homework, they might ask you to find the log of 0.6. But what you can do, 0.6, what is that as a fraction? 6/10, which is 3/5. So don't let it throw you off. If they give you a decimal, change it back to a fraction. Do you remember how to do that? Just read it. That's in the tens place, so 6/10, reduce it. That's the same thing as 3/5. So just giving you a heads up, if they ask you to do that on your homework, there's a good chance that you can change it to a fraction and then use the same rule. So all we've got to do is 0.4771. Y'all go ahead and start subtracting that. Minus 0.6990, which is negative 0.2219. So the log of 3/5 is a negative number. Any questions? The last rule is your power law. And this is pretty easy. It's the one that's most commonly forgotten, though. If you have the log of something to a power, the log of 3 to the 5th power, says that you can take that power, move it down front, and actually change it to multiplication. The log of 3 to the 5th power is the same thing as 5 times the log of 3. Okay, that's all the power rule says. You can take a power, move it down front, change it to multiplication. To me, it's odd why that works. Yes, you can. If you're given, and you'll have to do that some, 2 times the log of 3 is the same thing as the log of 9. Does that make sense? Why? Because if you move the 2 back up, and that is possible, you can move it back and forth. Yes, subtraction, division, because this looks better. If it says to simplify it, instead of 2 times log of 3, I'd rather have log of 9. So, that's it. That's it. Given that the log of 3 is this, find the log of 9. So the log of 3 is 0.4771. Log of 3 equals 0.4771. It asks you to find the log of 9. Does it make sense how you're going to do that? The 9 is the same thing as 3 squared. So instead of putting a 9 there, put a 3 squared there. So log of 3 squared is the same thing as 2 times the log of 3, which we know. Log of 3 is this, so you get 0.94, what'd you say, 0.9, 0.1, shouldn't be. Do you do 2 times this? You can't square it. Because, again, look at what we're doing. Log of 3 is this. We're trying to find the log of 9. So that makes sense to everybody. This is the log of 9. 3 squared is 9. We're going to move the 2 down front, so you now have 2 times the log of 3. 0.9542. So 2 times log of 3. But you can't, does it make sense why you can't square it? This, when you have the log of 3 squared, the log of 3 is not what's squared. What's squared? Just the 3. Okay? Makes sense? When you move the 2 down front, the whole thing is being multiplied by 2. So if you wanted to, you could type it in log of 9, you're going to get the same answer. Okay? But this is practice using your laws. You can move the 2 down front, do 2 times log of 3. We know what log of 3 is. So therefore 2 times that would be, like she said, 0.9542. Now we're asked to use pretty much all the rules. They're not going to tell us which one to use to find the natural log of 27, natural log of 0.7 repeating, and the natural log of 49. We're given the natural log of 7. Do this for me so I don't have to pop it back up. Ben, remember natural log of 9. Christina, remember the natural log of 3 for me. Can y'all memorize that? natural log of, what was yours, Ben? Which is 2 point, and Tina, yours was the natural log of 3. Thank you. And we're asked to first find the natural log of 27. And we've got to somehow use what we're given up here, these three things, to find the natural log of 27. What are you going to use there? 9 and 3. We can rewrite the natural log of 27 as the natural log of 9 times 3, which is the natural log of 9 plus the natural log of 3, which all you got to do then, here's natural log of 9, here's natural log of 3, add them together. And you get natural log of 27, therefore would equal 8, 15, carry the 1, 19, carry the 1, 2. Anybody get 3.2958? Maybe plug that in. Let me show you something though. That's not the only way of working it. Cody kind of had the right idea a while ago. He said something. If you know the natural log of 3, they didn't have to give you the natural log of 9. You can find that really easy using the natural log of 3. The natural log of 27, is everybody okay? We could also have done 3 to the third power there. Which would have been, how can we use natural log of 3 to the third? What's that the same thing as? 3 times the natural log of 3. So we could have also took this and just multiplied by 3 to find the natural log of 27. Either way would have worked. Makes sense? Next up. Natural log of 0.7777, 0.7 repeating. And again, if they give you something like this, then more than likely you're going to be able to change it to a fraction and use what you know. Does anybody know what 0.7 repeating is? 7 ninths. 0.7 is 7 tenths. 0.7 repeating. Let me show y'all. If y'all don't know this already, if you'll watch, I'll show you how to change a repeating decimal to a fraction. 0.7 y'all can do. Y'all did it a while ago. Like Cody said, that's 7 tenths. 0.8, 8 tenths. 0.9, 9 tenths. What you do is when you have something repeating, you take one away from the bottom. Instead of 7 tenths, it's 7 ninths. 0.777. 0.6 would be 6 tenths. 0.6 repeating would be 6 ninths, which is 2/3. That's how you do when you have something repeating. So therefore, 0.7 repeating is 7 ninths. So the natural log of 7 ninths, how do you find that? Natural log 7 minus natural log of 9. So you'll take this minus this. So 1.9459 minus 2.1972. Anybody want to plug that in for me? Negative 0.2513. Okay, sounds better. You threw me off because I knew 1 minus 2. I didn't think it was going to give us negative 2. Do you notice something though? When you have a fraction, you have the natural log or the log of a fraction is usually a negative number. That is usually the case. The last one, natural log of 49. How do you do natural log of 49? 7 squared, or 7 times 7 will work too. Move the 2 down front, that's going to be 2 times natural log of 7, so all you have to do is 2 times this, and that'll give you the answer. We don't have to type it in. Y'all know how to do it. 2 times 1.94, 3 point something, 3.8, 3.9 something. Any questions? That's all your rules. Next up, we're asked to use the rules, and again, all this lesson is using these 3 rules to simplify, to change things around. It says, write the following expression as a single logarithm. Got the natural log of x squared plus the 3 times natural log of y. And Brittany's question a while ago is going to come into play here. Can we change it back and forth? Yes, because we're actually doing it backwards now. Natural log of x squared, we're wanting to write this as a single logarithm. So is there any point in bringing this down front? No. You actually want to move as much up as possible. So first step, we're going to write this as natural log of x squared plus the natural log of what? Y to the third. Again, that third rule, that power rule, says numbers up front or numbers in powers can be moved back and forth. Everybody okay with that? The next one is your product rule. The natural log of something plus the natural log of something will be written as the natural log of times y to the third. We wrote it as a single logarithm then. Makes sense. That's it. Because, again, the directions just said write this, because you had two logarithms up here. Write it as a single log, move everything up in the powers, put it compacted, put it together. The next one, log of 10x plus the log of 20y minus 1. This is a little bit ugly. This one's going to require some thought. Any ideas? Good job. We are going to do that. But this is one of those to where you have to kind of think ahead about why you're doing what you're doing. Can't get it by itself. It's not. You don't have an equal sign, so you can't. Watch this. I'm only going to split the first one. I have my reasons. Because that minus 1's throwing me off. Because how in the world do you write minus 1 as a logarithm, right? There's no way to change that into a logarithmic form, so more than likely something's going to cancel out. And I think you have something on your homework like this. Anybody know what the log of 10 is? 1. So do you see what's going to happen with 1 and minus 1? They cancel each other. So that's the reason I just split that first one. So you got log of 10 and minus 1. Log of 10 is 1, so 1 minus 1 cancels. So you're only left with the log of x plus the log of 20y. Okay, we're wanting to write it as a single log. So if you split it, now you got 3 logs instead of 2. Log of something plus log of something, condense it. Just put those together now. Yeah, log of, and let's put them in alphabetical order just for the fun of it. Log of 20xy. Log of something plus log of something, combine it using multiplication. Log of 20xy. Any questions? That was fun. I like these. They're puzzles. Next problem. The 10. Log of 10. Y'all do need to get used to this. What you're asking here, what's the base there? 10. If nothing's there, it's understood to be 10. You're saying 10 to what power is 10? Or, go back up here.